Assalamualaikum and very good morning. So today we will present our assignment for course BERT3393 Telecommunication Switching System. Our lecturer is IR Muhammad Safiri bin Karis. So now I will introduce our team members. We have Muhammad Syamil Amirul bin Suhairi, Nur Anisah binti Kamaruzaman, Tushantan anak lelaki Kumar, and the last one is Wan Aina Zahra binti Abu Bakar Siddiq. So we start with our introduction. So this project focus on designing a reliable, scalable, and cost-effective local exchange to support 1,000 users. By using Kisco Packet Tracer for a simulation, it validates a modern design that integrates advanced technology to optimize performance, manage voice and data traffic efficiently, and ensure long-term scalability and adaptability to future demands. Now we continue with executive summary. We have the challenges and solution. For the challenges, we need to design and evaluate a cost-effective local exchange system that capable of 1,000 users and ensuring that is scalable for a future expansion. For solution, we have a four step right here. We have need a high capacity switching, ensure robust infrastructure, reliable signaling enables effective communication. The third one is financial planning, ensure cost efficiency, and the last one is use Kisco packet tracer for the validate system performance.
So for the objective, firstly, to construct a robust and scalable system architecture with essential components, including switching system and signaling equipment to efficiently manage voice and data traffic up to 1,000 users. Second, to evaluate equipment, software installation, and maintenance costs while testing the system reliability and scalability using Cisco Packet Tracer under varied load conditions.
Hi, I'm Kishandan son of Kumar. Now I'm going to present about the technical design, and this is a topology for the network design for multi-floor office. The setup is for support 100,000 users for across 4 floors. Core switch is Cisco 3560 24 PS and it's managed all the connection. For VLAN is VLAN 10 data, its IP address is 192.168.10.1 over 24 and the VLAN 20 is voice 20.10.10.2 over 24 and this traffic segregation keep the data and voice traffic separate to reduce the congestion, and the router is Cisco 2811 connect to the core switch and serve as the gateway and wipe integration with the CUCM, and the connectivity each floor is its subnet connected to the core via trunks limits to the combined voice and data traffic. For the first floor, green zone, the first floor consists of a mixed PC4 with the IP address 192.168.10.15 and the laptop one is 192.168.10.8 and the IP phone is IP phone 2 20 10 10 and 16 over 3000. All are connected to the local 2960 switch. The device communicate efficiently with their VLANs ensuring the uninterrupt the operation. For the second floor, it's pink zone. The second floor is similar to the first but as the higher concentration of IV bond and IP1 with 367 with the IP address 2 10 10 and 11 over 15 over 13 and the PC with PC5 3 and 6 with the IP address 192.168.10 9 over 9 over 11 over 7. The local switch with 2960 dash 240 enters communication within the floor while the connecting to the core switch for the enter flow and the external communication. For third floor is the blue zone. Much like we see on the second floor, the third floor also spot a local 2960 over the 240T switch, one for the connecting a number of IP phones with IP address 2 10 10 10 14 and 19 and PC2 and PC7 with IP address 192.168.10 and 6 and 192.168.10 point and 12 as well as laptop. With this VLAN 20 configuration, it's possible to facilitate a practical wipe and communication system. And the fourth floor, yellow zone, therefore on the fourth floor, you can see the whole criteria as can be seen from the other floor using a mix of IP phone and IP phone 0, 5 and 8 with the IPS 20, 10, 10, 12 over 18 and 17, and laptop IP with 192.168.10 and 14, and the PC with PC 0 and PC 1 with the IP address 192.168 and 10 and 13 and 192.168.10, which more throughout its local switch connecting all the ensuring VLAN segregation. Thank you.
Okay, so for the financial analysis, we have a hardware cost, software cost, installation cost, and maintenance cost. And also we have budget breakdown and the total cost estimate. So for the hardware cost, we have estimate price for the router, multi-layer switches, IP phones, PCs, laptop, and structure cabling, and it costs for the total 40,700 ringgit Malaysian. Okay, for the estimate price for the software cost, for the item Cisco Prime, CUCM, security software, server OS is 21,200 in ringgit Malaysia, and for the installation cost, if for the cabling installation, hardware installation, software setup, license for software, configuration and testing, power and cooling is 43,000 ringgit Malaysia. For the maintenance, which is annual maintenance, support contract, network monitoring service, license renewal and training is 20,000. For the our budget breakdown and total cost estimate for our project is RM 124,900. So for the initial total cost, basically is for hardware software installation is RM 104,900. So for the annual maintenance after initial setup is 20,000 per year.
Next, I will proceed for the methodology and simulation. My name is Muhammad Syamil Ambirul bin Suhairi. My metric number is B08221023. So, this simulation methodology describes the step-by-step processing of simulating the broadband internet service deployment using the Cisco packet tracer. The methodology involves the designing, configuring, testing, and validating the network topology of a multi-floor company buildings. So, in this topology, we use one Cisco 2811 router and multi-layer switch 3560 2PS as the center routing point, and then 4 Cisco switches, which is Cisco 2960 for each floor, and it can handle 250 user each one. And for the end device, I'm using the IP phone and PCs, also the laptop. The connection for multi-layers to the router is using the trunk links. I'm using the port FA01, and for the multi-layer switch also FA01. So in this multi-layer switch, I already assigned the local exchange, which is VLAN 10 for data and VLAN 20 for voice. In the router configuration, I already assigned the IP address to router interface, which is 23.23.23.2, and configure the inner VLAN routing using sub interface. For multi-switch, I create the VLAN voice and VLAN data, and all the switch I also assign all the VLAN to each switch and each floor. To verify all connection, we can check it by using this command sh running config. You can see in this switch already have internet interface fast internet 02 to 23 already have the switch port access VLAN 10, switch port mode access, and switch port voice VLAN 2, and also the spanning tree port fast for the faster connection. Same as all the switches, I already put it, the VLAN. As you can see, it already says VLAN 10 already been assigned on these switches. And then for the main connection, I'm using the trunking links for inter-switch communication. On the IP phone and PC, for IP phone, on IP phone, we use the DHCP and a CUCM server information to assign all the numbers and IP address. Also for PC, I already assign it on the DHCP, and then we automatically appear the IP address for each PC using the DHCP. And then we will test the latency, packet loss, and jitter for each connection. To this PC on the floor 4. As you can see, from floor 1 to floor 4, sending a mail, the data reply is receive, 4 send, receive also 4, and 0 loss. The average time speed is 10 ms and average of 2 millisecond. And also I'm testing it to the from floor 3 to floor 1. Also good connection, 4 send and receive also 4 and 0 loss. And then lastly we'll check for the last floor, which is floor 2 to floor 1. Also have a good connection, which is I send 4 packets and receive 4 packets and 0 losses. And then for the last one, simulation, I will check the IP phone connection. The IP phone also have already been assigned with the numbers. For phone 0 at floor 4, 4000, and using floor 2 is 2000. For phone 3, we will try to make a call. Okay. Out, and the phone on floor 2 also ringing, and it's already connected. I also will try from floor 4 to floor 3 on phone 1. 1000. So that's all for the simulation, and we'll proceed for the next slides. Thank you.
So in conclusion, this project successful design, simulate and validate a local exchange system to support up to 1,000 users, addressing common challenges in scalability, reliability, and cost effectiveness within a telecommunication industry. The simulation performed using Kisco Packet Tracer demonstrate the system technical feasibility and resilience under varying conditions. So the financial analysis not only guarantees affordability but also strategically lays the foundation for a future growth and scalability. So for the last one is our recommendation. We have four things right here. From vendor selection, testing optimization, scalability planning, and the last one is implementation strategy. So for the vendor selection is we need to establish a maintenance contracts to reduce long-term operational costs. For testing and optimization, we need to refine the system design to maximize efficiency and further reduce costs. And the third one is scalability planning, is to create a comprehensive roadmap for future scalability, including provision for increased user capacity and additional features. And the last one is implementation strategy, is to provide comprehensive training for operational staff to ensure the system is efficiently managed and maintained. That's all from our group. Thank you.